Alright, this is 5.3, logarithms and their graphs, and this is part 4. Alright, so we're going to talk about changing logarithmic bases. If you take a look on your calculator, you're going to see that there's really only two possible options. Alright, in one case it's going to be our log base 10, and that's right next to our 7. And then my log base e, my ln, my natural log, is going to be right next to the 4. And those are the two that we have. Now, we've already talked about and had a couple of instances where we had a log base 2, and a log base 3, and a log base 5. So beyond the log base 10, right, we have other ones that we're going to have to be able to address. In order to be able to do that, we have to find a way to take one or the other of these two and convert it into whatever form, whatever base we need. Okay? And here's what's going to happen. So we're going to take our log, we're changing it from our old log, our log base 2, in this case, with our m being a 32. And then we're going to take our log base 10 and put that with a 32. And then we're going to divide by log base 10 with our 2 for the base. Alright? And that's going to give us our process. So here we're looking at our a is the new base that we're using, either our log or our ln. And then we're using whatever our original base was to become the denominator, log base, the new one, and then that value. Let's go ahead and take a look at the next page. So in this case, we're going to have log base 5, and we're going to find 8. And we're going to do that solving using our one of our two types of logs that we have on the calculator. Alright, so this is going to give us our setup. We're going to use a log base 10. We have right now a log base 5, and our number that we're looking at is going to be the 8. We're going to substitute this all into our change of base formula. Alright, so here's our log 5, 8. We're going to change that log base 5 into a log base 10, 8, divided by a log base 10, 5. And so we're going to get a 1.292 as a result. And in this case, we're going to do the same thing, except we're going to use the ln, the natural log. So here we're going to use a log base e. We say log base e, really that's just our ln. Our log base 5, 8 is going to have our log base e, 8 over log base e, 5. And it's going to reduce down to an ln 8 over ln 5. And again, that's going to give us our 1.292. I want to point out one thing. Once you pick which log you're going to use, whether you use the natural log or the log base 10, once you pick, you have to stick with it. You can't do a log base e here and then in the denominator use a log base 10. That will not work. You need to, once you pick, you have to stay with it, at least for the rest of the problem. All right. So here's a reasonableness check, and I've kind of mentioned this. I want to make certain that it's real clear. One of the things we want to do is we take a look at log base, whatever, and see if our number falls where it falls in between, and is our result reasonable. So if I have a log base, well, my 8 is going to fall between 5 and 25, right? So I have one exponent, and then I have a 2 for an exponent. So in between those two, I'm going to have an 8. So my log base 5 is going to be bigger than 1 but less than 2. And in this case, our 8 is much closer to the 5 than it is the 25. So it's reasonable that we would find our log value being closer to the 5, or closer to the result of 5, which is a 1, than the exponent of 2. So we've got that 1.292 going on. Alrighty. Here again, we're going to talk about, we've got our log, right? Our y, we find our exponent, then we calculate our values, and this is what it's going to look like. You're going to have some kind of curve that it bends closer and closer to the y-axis, and that will be only if there's nothing else moving it one way or the other. But it's getting closer and closer to the y-axis. It will never touch it, and it will never cross it. And then it comes up, and it kind of curves up and then flattens out. It's still increasing, but it's increasing at a very slow rate by the time you get out a little further, right? When you go from 25 to 125, that's 100 spaces, and you go up one number. So that's that can be kind of a little mind-blowing there, okay? So we're going to take our log, and we're going to switch around our x and our y, right? So you have the log base 5. If our original result was 5x equals y, you're going to switch these guys around to get this same value. And then you're going to go ahead and calculate, which we just did. The other way, the next way you could do it would be using it on the calculator. And you can just enter this into your calculator, just like this. And you put it into your y equals. And you would use your log base 10x over log base 10 5. Let's take a look at that. So we're going to use our log base 5 of x. I'm going to have my natural log. I can use natural log or log base 10. Natural log of x over my natural log of 5. And that's going to give me the same value as log base 5 x. And the third method, there are some calculators, not all of them, but there are some calculators which, if you tell it to use the inverse of something, where you'd have like the function and you have that -1 x, so you're saying you have the inverse function of the original function of x. So this is, I realize that's a mouthful, and conceptually it's like the inverse of, say if you multiplied something by 2 and then you divide by 2, those are the inverses of each other, or you multiply, you square something and then you take a square root. Those two are undoing each other. So there are, on some calculators, there are options where you can use this, and then you tell it which y to look at, and then it will automatically draw that for you and give you that information. But in this case, on my calculator, I don't have that as an option, so I'm not really able to show you how to do that. All right, I'm going to stop here, and we're going to go, let me just finish this page up, and then we'll come back to this in our next part.